I am going to attempt my first online streaming video. So what I have here is my PowerPoint, and I will be narrating it as I usually would in class. The words that you have to fill in are in blue, so you should be following along with your usual notepacks, filling in the words as you go, listening, and then you'll have to do your workbook when we're done. So this is just a video, which means you have the flexibility to pause. You can go to the bathroom, get a snack. You can come back, do this another day, do it in chunks, whatever you need. Okay? All right, here we go. Okay, today's lesson is on biogeochemical cycles and how these cycles get kind of affected and disturbed in our environment. So by the end of this section on geochemical cycles, you should be able to illustrate and explain the carbon, nitrogen, and a little bit of the oxygen and how they are cycled through an ecosystem, and discuss natural and human activities that disturb these cycles. So what is a biogeochemical cycle? That's a bit of a mouthful. So we have to kind of think a bit back to our ecosystem. How are living things interacting with their environment? So there's kind of two components here. There's energy and there's nutrients. So one of the things you should have caught on to when you were talking about food chains is that in an ecosystem, energy cycles in a one-way direction, which means it doesn't actually get cycled back through the ecosystem. It has to constantly enter through the sun because energy gets lost at each movement up the food chain. So remember, 90% of energy gets actually just lost as heat. Nutrients, on the other hand, are actually cycled. So they can be recycled over and over again through food chains, through ecosystems. So that is where these biogeochemical cycles come in. This is where nutrients, not energy, moves through organisms and the environment and back again. So this might be the movement of carbon, where it goes from a plant to an animal, the animal dies, it goes into the soil, then maybe, gets decomposed and that carbon dioxide enters the air, then photosynthesis takes place and it goes through a big process. So some of the nutrients that can do this are carbon, phosphorus, nitrogen, sulfur, and oxygen. Okay, so let's break down that word biogeochemical cycle a little bit. It's a big word, sounds like it's very complicated, but if you understand the kind of root of each part of that word, it makes sense. So starting there with bio. Bio simply means referring to life. So when we study biology, this just means the study of living things. Geo means referring to the earth. So geology is the study of the earth. Then we have chemical. This is where we're going to be referring to the elements and compounds. So thinking back to chemistry, oxygen, carbon dioxide, nitrogen, hydrogen. That's what we're going to be referring to with this. And cycle. Cycle is movement in a regular, repeated, typically kind of somewhat of a circular pattern, but does not have to be. So if you put these all three together, for biogeochemical cycle, this is where nutrients and chemicals like nitrogen, carbon, and oxygen cycle from living things to the earth and back again in somewhat of a regular and repeated pattern. So an example that you would have been familiar with from probably younger grades is the water cycle. So water is a compound of hydrogen and oxygen, and it cycles from living things into the air, into the clouds, condensates, precipitates, down to the ground, and back again. Okay? So that's a regular repeated pattern of water cycle. We also will be talking about carbon and nitrogen in detail, and knowing that the oxygen and carbon cycle are very closely linked. So the lesson today is going to be mainly on the carbon cycle. So the carbon cycle is simply going to be the cycle where carbon moves through an ecosystem, through the organisms, through the earth, through the atmosphere, in somewhat of a pattern. So carbon, if you think back to that element on the periodic table, carbon is actually a very key element in all living things. You, me, your dog, your fish, We're all made largely of carbon. It's also in our plants and kind of anything that is living. Now, carbon gets cycled through the kind of air and earth through many processes, but two of the main processes that are most important here is photosynthesis and cellular respiration. Okay? You need to know these two processes. So if you're ever asked, what are the two main processes of the carbon cycle? It's those two there. Okay? If you wanted, you can come back and watch this video later here. So it just kind of shows photosynthesis and cellular respiration are the two main processes of this cycle. But there's also going to be decomposition, fossil fuel combustion, breathing kind of added in there as well. Okay, so focusing on photosynthesis and respiration. These two processes are closely related in that they kind of work together, but they're truly opposites of each other. If we think about carbon dioxide in the atmosphere, that carbon gets removed from the atmosphere through the process of photosynthesis. So plants actually take in that carbon dioxide and they convert it into glucose. So carbon dioxide is the form of carbon that is harmful to our environment. It leads to that global warming that we'll talk about later. Plants are able to take in that carbon dioxide, convert it into a sugar for their food, which helps kind of remove that pollutant from the air. Then, in plants, that sugar, that glucose, might get converted into an animal just by being eaten. And then animals undergo cellular respiration, which breaks down that glucose and the sugar in the food and converts it and releases carbon dioxide as a byproduct. Okay? So these are opposites. Photosynthesis. Plants absorb carbon dioxide and convert that into glucose, okay, a form of sugar, C6H12O6. Animals then take those sugars in our food, we undergo cellular respiration, and we return that carbon back in the form of carbon dioxide. So these two cycle together very closely. Okay, photosynthesis takes in carbon dioxide, releases oxygen. Respiration and cellular respiration take in oxygen and release carbon dioxide. So these two cycle together, but keep in mind they're not the only two parts of the carbon cycle. Keep in mind here, oxygen is also playing a role. So we're not going into detail of the oxygen cycle itself, but if we take a look at these formulas of photosynthesis and cellular respiration, these two equations involve both carbon dioxide and oxygen, right? And if you look carefully at these formulas, they're actually pretty well the perfect reverse of each other. Okay? So if you look carefully, we've got our reactants and our products, and they are the complete flip of one another. Pardon my messy arrows, etc. So plants are actually able to perform both photosynthesis and cellular respiration. That's very important to keep in mind. We often think of plants as doing photosynthesis, but once they actually have that sugar stored within them, in order to be able to break down their own food sources and get energy from it, they then have to go through cellular respiration just like you and me. Animals are a consumer. We're not capable of doing that photosynthesis. Therefore, we have to eat our energy. We have to eat plants. We have to eat other animals in order to obtain that glucose in the first place. Then we undergo cellular respiration to release that energy out. Okay. So carbon gets cycled back and forth in these two between the atmosphere of carbon dioxide into kind of a stored form of the glucose and back to carbon dioxide. All right. So this next slide here, this is a picture of the carbon cycle. Now again, look, it's not a perfect circle. Okay, carbon gets cycled in a regular repeated pattern, but there's not one path that a carbon dioxide atom might take here. Okay, so a few of the key processes here is we have our photosynthesis and our cellular respiration. Okay, so that's what we were just talking about. We see the carbon dioxide in the atmosphere. Photosynthesis is taking it in. Respiration from plants and animals is releasing that carbon dioxide. But in addition to just that little cycle there, we have burning of fossil fuels. Okay, this is going to release a lot of carbon dioxide into the atmosphere. Keep in mind, remember, if we think of those combustion equations from back in chemistry. The other process we have going on here is decomposition. So detrivores is kind of another word for decomposers. So when we have plants and animals and they die, they leave this detritus, which is just dead, animal and plant matter. Decomposers break that down and release carbon dioxide from their kind of carbon in their body, release it back as carbon dioxide into the atmosphere. Okay, so that's another component there of the carbon cycle. Okay, beyond just cycling, we also have on our Earth carbon sinks. These are going to be things that are capable of absorbing or storing more carbon dioxide than they release. So these are essentially just big sinks that are able to store carbon dioxide and keep it from entering the atmosphere where it becomes dangerous for greenhouse gases. The first carbon sink we're going to talk about here is oceans. So we know oceans are really large bodies of water all over our planet here. They're actually capable of carbon dioxide will dissolve itself within the water. And then it also gets absorbed by aquatic plants and algae for photosynthesis. But there's going to be a lot of carbon dioxide just kind of sitting in that water out of the atmosphere so it doesn't lead to global warming. So oceans are going to be kind of a key carbon sink. Plants and forests, especially, forests contain tons of trees, great carbon sink. They are capable of absorbing a lot of carbon dioxide from the atmosphere and storing it in the form of carbohydrates in their trunks and in their roots. So that helps, again, keep the carbon dioxide out of the atmosphere. Soil is actually also a carbon sink. So in the soil, when plants die, some carbon dioxide will get back into the atmosphere, but some will actually just get trapped and transferred into the soil itself. Okay, so oceans, plants, especially forests, and soil are known as carbon sinks, okay, where they are capable of absorbing and holding on to more carbon dioxide than they release. We also then have other forms of kind of temporary carbon dioxide storage, can also be considered a source of carbon dioxide when they kind of release it. So these are not necessarily beneficial. They are kind of temporary carbon storage, but often can release it then in the form of carbon dioxide at some point. So the first culprit here is fossil fuels. Fossil fuels are coal and oil and natural gas. They're a form of carbon that is trapped deep within the earth ever since kind of the Carboniferous period. Fossil fuels themselves are actually not bad. When they're trapped within the earth in the form of coal or oil, it's not harmful to the environment. What happens, however, is humans then extract that oil, coal, whatever you have, and then we burn it. When we burn it, that's when we're adding that carbon dioxide. So fossil fuels are considered somewhat of a stored form of carbon. When we burn them, that's when it releases large amounts of carbon dioxide. And you can't get it back into that coal or oil form. So it is a non-renewable resource, which is what makes it so tricky. Okay. All right, next we have forests. Now, I know I mentioned forests as a carbon sink. Because they are capable of storing large amounts of carbon, in the event of forest fire, they can also release a lot of that carbon in the form of carbon dioxide. So that can be, a form of temporary storage that can lead to release. Other forms of carbon storage and release are living organisms. So as I mentioned at the very start of this lesson, carbon is present in all living things. It's stored in our bodies. But when we die, or, naturally, if we were to decompose naturally, like a bird or a bunny, or leaves even, that carbon gets broken down and then decomposed and releases carbon dioxide. This is just another depiction of the carbon cycle, again, showing you a few other processes. So we, of course, have the respiration, and we have the photosynthesis. Okay. We also have that burning of fossil fuels, adding carbon dioxide into the atmosphere. This picture shows the carbon sink of ocean. So it's getting, dissolved into the ocean there. And we have some decomposition, releasing carbon dioxide. So it's going to be very important that you know a few different processes of the carbon cycle, that you would be able to show the flow of how carbon dioxide is either entering into the atmosphere or being removed. Okay, so that's kind of the carbon cycle. Now we have to talk about how does the carbon cycle get disturbed, or what affects that kind of regular repeating pattern. Okay, we can break this down into two categories: your natural and your kind of human activities that affect the carbon cycle. Natural events here, we already mentioned forest fires. So forest fires do contribute to releasing a lot of carbon dioxide back into the atmosphere. Not a lot we can do about this. There is, global warming has led to an increase of forest fires, but it is itself considered a natural activity. Another thing that we don't often think about, because we don't get a lot here, is volcanoes. So volcanoes actually release a ton of smoke and ash, consisting largely of carbon dioxide as well. And more so than just releasing that cloud of carbon dioxide is that it also, with all of the ash, it's actually going to block the sunlight temporarily. This will then reduce the amount of photosynthesis that plants are able to do, which then reduces the amount that those plants are able to absorb carbon dioxide in that process. So kind of two ways that volcanoes can, in fact, increase the amount of carbon dioxide in the atmosphere. Okay, then we have our human activities. So not just forest fires, but deforestation. So this is where we actually cut down trees. Deforestation removes the trees. Now, when you cut a tree, you're not just necessarily releasing the stored carbon, but you're removing something that was helping to remove carbon dioxide. So you're indirectly increasing the amount of carbon dioxide in the air by removing something that was removing the carbon dioxide. Sorry, I know that sounds really confusing. But basically it's kind of an indirect way that human activity is leading to an increase of carbon dioxide. So having plants, planting trees is definitely a good thing. A couple of facts here just about things trees can do for us there. All right, the other thing, and I'm gonna mention this over and over again, it's the main thing that humans do that messes with the carbon cycle, and that is burning fossil fuels. Can be in the form of gasoline. So we burn gasoline largely to power our cars. Okay, we burn coal in many places across the world, largely for heat, as well as natural gas. So gasoline, coal, oil, natural gas, these are our fossil fuels. We burn them to produce energy. The downside is that they release a lot of carbon dioxide. So what we've actually found is that studies have shown since kind of the Industrial Revolution is really when the concentration of carbon dioxide started to spike. So in 1750, when there wasn't really vehicles and there wasn't really factories and there wasn't really a lot of industry going on, they found that there was around 280 carbon dioxide molecules in every million air molecules. Okay, so that is written as, if you ever see the unit ppm, let me see if I can write this here. ppm stands for parts per million. Okay, so you would write this as 280 parts per million. Now, that is kind of our baseline. Okay, that's kind of the amount of carbon dioxide molecules in the air at baseline without a lot of human activity. What we have found then is by 2007, that number had increased to 380. And the most recent number I could find was in 2018, that number had increased to 407. So we are seeing, in kind of the last 150 years, a drastic spike in that carbon dioxide concentration. The main difference between now and then is, human activities, increasing cars, increasing industry, all of that kind of stuff. Okay. So why is that bad? Now, I'm sure you've heard of this before. We're not going to spend a ton of time, but the reason carbon dioxide in our atmosphere is bad is because it contributes to the greenhouse effect. Okay. The greenhouse effect then leads to the warming or global warming of the planet, also known as just climate change. So please don't tell me that just because it snows, we're not experiencing global warming. Okay, this greenhouse effect also just creates, general change in climate patterns, can cause more hurricanes, can cause more tornadoes, can cause more just forest fires, and dramatic natural disasters have been kind of linked back to this greenhouse effect. So this is just a depiction of the greenhouse effect. So there are certain gases called your greenhouse gases: carbon dioxide, methane, carbon dioxide. They kind of create a little bit of a layer here on our atmosphere. So typically what's supposed to happen is sunlight's supposed to come in, some will get reflected off of the earth, and some is just going to kind of bounce out of the atmosphere. What's happening now, is with these greenhouse gases, they're creating a bit of a barrier. So when the sun's energy comes in, it's no longer reflecting out. It's being trapped within the barrier, leading to kind of excess sun energy, excess heat, which warms the planet gradually. Now, scientists have found that it doesn't take a drastic warmth to create, dramatic problems or dramatic changes. So some of the things that we were seeing is obviously melting of ice caps. Now, white is a color that actually reflects sunlight. So as we melt snow and ice, which leads to more water, we're eliminating something that used to reflect sunlight, and now the water is dark and it absorbs light, leading to more warming of that water. So we're seeing, melting of those ice caps. We're seeing then sea levels starting to rise, flooding. Coastal cities are starting to see this, more flooding year after year. We're getting a change in climate patterns, more droughts. This can be really, dangerous for agriculture if they have to deal with more droughts and less rain. This can lead to more asthma, respiratory issues as, just air pollution increases. So those are just some of the effects of the greenhouse effect and, climate change. But feel free to kind of do your own research on that. I'm sure you've talked about it before. Okay, the last thing you can actually do there is, if you wanted, you could look up what is called a global footprint calculator. It would ask you a series of questions to determine essentially your impact on the earth, relating primarily to your carbon dioxide footprint. So it'll ask you, how big your home is, how often do you carpool, do you walk, do you take the bus? It'll ask you, do you buy local? All of those things are behaviors that we do that, can affect the amount of carbon dioxide that our actions are putting into the atmosphere. Okay, that was kind of our first lesson, carbon cycle. So you should have a, familiar feeling with what the carbon cycle looks like. You're going to need to draw that. You need to know the two main processes are photosynthesis and cellular respiration. However, the other two key things is going to be your combustion and your decomposition. You're going to need to know then some of the natural and human activities that disturb that cycle. Okay, at this point, you are supposed to be practicing on your own. So if you've been keeping up with everything up to this point, you should be at page 10 and 11 in your workbook. And when you're done that, or as you go through that, you can message me with questions. All right, hope this worked for you. Thanks and good luck.